Hey guys, this is a video lesson on significant figures, which is covering for IPS. This is actually covering chapter 3.4, which is dividing and multiplying measured numbers. And this is going to go a little bit beyond that chapter and cover a little bit more specifically with significant figures and more than just dividing and multiplying. So this is the overall objective of what we're going to cover. And we're going to start by just going right into some measurements on our ruler. If you want to um, try out these measurements first on your own, then I suggest you pause the video now and then you can record your measurements. And these are the measurements if you did that. Welcome back for pausing. And I'm going to come back up in just a second and tell you why this 0 is highlighted in red. Um, Basically, if you remember, we learned that significant figures are figures that we go to the tick marks on the measuring device plus one more digit. And we look at any number that is after that decimal point to be a significant number, meaning it's got significance in the measurement with what we can measure for the value of this particular instrument. We do not consider starting zeros like this one here highlighted in red to be a significant figure. What that means is it's not really adding any value um, to this measurement. It's just a starting zero. It's really more just a placeholder. So really, when you're writing these measurements, they really should be written out with another zero after each one. Get off the highlighter here. Right, so we would have another 0 here. That's what you see here, 0.50 and 1.9. It really should be 1.90, okay, and so on. And that's again because we are wanting to go to the tick mark plus one more digit. And we're saying that this is pretty exact in all of these cases, and so that's why we're getting the 0. Really, truly, somebody may argue and say it could be 1.91. Um, but that would be just based on your judgment of where that arrow is actually pointing to. Okay, so these are the rules for significant figures, and these are really important for you to know and understand. And so you may want to pause and rewrite these or put them in another place. We'll also follow up with these in class. So we're going to start off with the rules. The basic rule is, of course, if it's a non-zero number, all right, 1, 2, 3, 4, 5, 6, 7, 8, 9, whatever, any non-zero number, that is always a significant number. Done. Okay. Any zero that is between non-zero numbers is also always significant. So if we had, for example, the number 101, then that, of course, those ones are significant figures. They're non-zero. And then this zero, because it's in between the two ones, that would also make it a significant figure. Any zeros that are simultaneously to the right of a decimal point and at the end of a number are always significant. So again, if we had something like 1.30, okay, this is to the right of the decimal point and is at the end of the number, and that zero is a significant figure. And then all zeros which are to the left of a written decimal point and it's a number greater or equal to 10 are always significant. And what that means is if you had something like 10.3, okay, this is a 0 that's to the left of the decimal point, and it's again after a non-zero number. It's going to be any number that's greater or equal to 10. Um, that's always going to be significant. Um, again, we're using significant figures here to report the data scientifically with a great deal of accuracy, and it really will depend on the precision of instrumentation that you're using. And so I'd like you to recall a triple beam balance if you could, and try to think about what numerical column the triple beam balance is read to. So think about it, pause it, because here I go. Hundreds column. Hopefully you got that one right. Okay, so this is a little fun little game that we're going to actually pull down in class. So I just want you to take a peek at this. You can pause it We're going to be looking at how many significant figures are in each of these numbers displayed. And here we go, just a little bit more. Okay, and we'll continue with that one in class. Okay, so now some rules for dividing and multiplying, adding and subtracting measured numbers. This is a really important, these are really important rules here, so you have to make sure that you are definitely remembering these rules and applying these rules. Okay, so anytime you're going to divide and or multiply numbers, then you're going to want to make sure that the final answer gets reported using the least number of significant figs. We call them sig figs for short. Okay, for an example, and this is an example in your IPS book, you have 4.82 centimeters, 11.05 centimeters multiplied by 1.28 centimeters. You do that in your calculator, you get this long number, 68.174,080 centimeters cubed, right, or cubic centimeters. However, again, you want to make sure you're reporting the final answer using the least number of significant figures in the data. What that means is that your answer, your final answer, cannot be more accurate than the accuracy of your data that you're reporting or the precision of your data. So you look over here and we've got, okay, this first number here, 4.82, this has the 4 is a significant figure, the 8 is a significant figure, and the 2 is a significant figure. So we've got 3 significant figures in that number. Here we have 11.05. This is significant. This is significant. Of course, the 5 is a non-zero. That's significant. The 0 here, again, because it's in between two non-zeros, significant figure. So here we have 4 significant figures. And then, of course, all non-zeros are always significant. Okay, so in this number here, we have 3 significant figures. So we have a 3 significant figure number multiplied by a 4 significant figure number, and then multiplied by a 3 significant figure number. That means the final answer has to be rounded to simply 3 significant figures, which is what we've done here. Notice that the full calculated answer is 68.17 and so on. And so we know we need to go to 3 significant figures. And so we're going to have to cut it off here. And so what we do is we look beyond this number 1 and this next number, because this number here is above 5. Anything if it's a 5 or above, then that's going to cause us to round that final digit up. So we rounded it up to 2. Okay? When we are adding or subtracting, anytime we're adding or subtracting, this is where we're going to use the least number of decimal places, different than multiplying and dividing. And so here, let's look at this number. We've got 1.23 grams plus 0.0032 grams. And just for the fun of it, again, looking at your numbers of significant figures, here we'd have a 3 significant figure number plus, remember, all these beginning zeros, they don't count. So we'd only have to count these 2, so that would be a 2 significant figure number. Okay, but again, we're adding or subtracting. So we're not going with least number of significant figures, we're going with decimal places. So when you add up the full number, you get 1.2332. We need to go to the least number of decimal places. The least number of decimal places is right here, 2 decimal places. So we need to round this number off to 2 decimal places, which is what we get here, 1.23 grams. Again, we looked at, okay, what is that final number here right after? It's 4 or less, so that leaves this number to stay the same. Okay, so rounding to correct significant figures, again, if the following number is greater than or equal to 5, you're going to round up. If the following number is less than or equal to 4, not really rounding down, I guess you could say rounding down, but you're really just keeping the number the same. And hopefully that makes sense to you. Just like what we did here with this number 1.23, and we kept the number the same, the 3. It's the final answer. Okay, that's it for your video lesson. Let's practice in class.